Okay, in this video, I want to talk about the procedures to test for heteroscedasticity, autocorrelation, and multicollinearity using the R package. Now, I've already loaded in the data set I want to play with in this video, but let me just show you the data that I have got. I have the Standard and Poor index returns across the given time periods, and I have the returns of a particular stock, which is Dell Corporation, which happens to be a constituent of the Standard and Poor index. And you see I have this for quite a decent number of time periods. So here I have time series data. Now, I've already read the data in because you've seen me read data in quite often. I have already been careful to set the date as a date type variable in R. Now, if I'm going to test for heteroscedasticity and autocorrelation, I need to have run the initial regression first. And I'm just going to do this in the usual way. I'll save the regression as an object called lm1. I'll do a linear model. In this case, I'm going to leave the data alone. I'm just going to test the idea that I can use the Standard and Poor return to predict the return of Dell. So I'm going to use Dell as my explained variable. Incidentally, I'm using Dell $Dell return because the data set, the data frame is called Dell. I need a tilde and now the other variable. And in the usual way, I'm not typing, I'm clicking the auto prompts because one spelling mistake can give me an hour of pain. Oops, it's lm1. And I've got the regression already run. I'm not really anticipating that this model will have a particularly strong explanatory effect. The financial theory behind this suggests that actually if the markets are strong form efficient, then this sort of analysis won't work. I am just eyeballing the R square, it's pretty low. I'm eyeballing the T value, and oh, it is actually significant. If you don't know how I've run the regression, then go back to the previous video where I explain a little bit more fully. In this video, I'm more interested in how to use R than how to interpret things and how to explain basic econometrics. The gist of this is I now have my regression. I've captured it in an item which I've called lm1. First thing I think I'll do is I'll do the heteroscedasticity test. Now in R, I will use a Brush-Pagan test. You have to be a little bit careful because we have a Brush-Pagan test for heteroscedasticity and a Brush-Godfrey test for autocorrelation. It's the same brush in both, by the way. If you use eViews, you may have chosen not to use the Brush-Pagan test. You may have used a white test instead. But in R, it is actually easier if we do the Brush-Pagan test. The hypotheses are actually the same as they are in the white test. So it won't be particularly difficult for you to adapt to this. And I'm sure most half-decent textbooks such as Jagatri will discuss the Brush-Pagan test. In order to do the Brush-Pagan test or the Brush-Godfrey test, I need to add a package into R, and the package I need to add is called lmtest. They're both actually Lagrange multiplier tests. Now, if I hadn't already installed the package, I would run that line. But since I have already installed the package, let me just put a hash and that'll cause it to become a note. Let me make sure I have lmtest active. I can just go to the packages tab over here and just make sure it's ticked in. It is actually ticked in, so I don't need to call that code either. But if I was doing it for the first time, I would call that code. I've already got the package in. If you don't have the package in, the two lines which I've just skipped, you need to run without the square sign at the beginning. I'm now ready to do the brush pagan test. The syntax is bptest. Now I need to give the name of the regression object I've run. Press enter. You see here, I have my bptest. It's on the regression. I have my bp stat value. I'm also given a p-value here. So I'm given the probability that I am going to accept the null hypothesis in the test. So if I'm a bit clever, I don't actually need to go to a chi-square table to look up the chi-critical value. I'll leave it to you to decide how you would interpret that brush pagan test. In a similar vein, I now want to change tack because I like these videos to go fast. Here, I want to do a Brush-Godfrey test. This isn't a test for heteroscedasticity. This is a test for autocorrelation. So we're testing for a different thing now. Rather happily, I've already installed the lmtest package, which you've just seen me do it, so I can skip straight to bgtest lm1. This gives me the Brush-Godfrey test for serial correlation. On this data, I have the test statistic here. I have the probability value that I will accept the null hypothesis in this case. So I very quickly managed to produce the test statistics for heteroscedasticity and autocorrelation. Those of you who are a bit turned on will note I'm not going to bother doing a Durbin-Watson test for autocorrelation. I'm much happier to use the Brush-Godfrey, which has the capability of dealing with higher order autocorrelations, unlike the Durbin-Watson. Usually when we are examining a model, we'll look at autocorrelation, heteroscedasticity, and multicollinearity. I usually tell my own students, and given this video is mostly for my own students, I would assume that you've already run the correlation matrix in MS Excel, and you've already had a think about what variables you will or won't include as part of the specification steps. Just a word to the wise, however, if you have got into R and you haven't yet run the correlation matrix, it's not really a problem. We can do it in R, and I'll just show you the steps for a margin of safety. If I have a data frame where every item in the data frame is numeric, I could actually run COR Dell. The problem is in this data frame, I'd have a date variable. It's not numeric. I would guess if I pressed enter, I'll get an error message, and I was right. Not to worry, my friends. because if I do core x comma then y, I'll get a correlation coefficient just between two variables. Rather happily, I do have just two variables here, so this will be nice and quick. Dell dollar Standard and Poor return, doesn't matter which way around I do this, Dell dollar Dell return. If I now return that, my Pearson correlation coefficient is decimal 0.41. So given that Dell's returns are actually a factor of the Standard and Poor returns, a correlation coefficient of 0.41 is a teeny bit low. I'm not worried to put these two in an OLS regression model together, so I'd be happy with that. I think this video is running round to 12 minutes now, so let's end it there. I might make one or two more videos. I'll see how I feel after this. Maybe it would be good to look at autoregressive structures in R because I can show you a real quick trick to run those. But for now, let's leave it there because that's enough for you to replicate in one day. As always, thanks for your time and all the best.